Hi folks, in this video we're looking at arguably the most complicated law of indices, and that is if we have a number raised to the power of a fraction, x over y. So a to the power of x over y. Now what that means is we take the y root of a to the power of x. That's a very complicated rule, but let's apply it a few times, get a bit used to it. So let's say we've got 8 to the power of 4/3. 8 to the power of 4/3. Now bear in mind that's the exact same thing as 8 to the power of 1.3 recurring. 8 to the power of 4/3. So if we saw this first, it might be easier to think of it as a fraction, the power. So if what I like to do is if we've got a number 9 and it's to the power of 0.5, I would think of that 0.5 as just a fraction. If you convert any decimals in powers to fractions first, it makes them a little bit easier. So 8 to the power of 4/3. So we need to, the bottom number is 3, so the y in our rule here is going to be a 3. So that means we're taking the cubed root of 8 to the power of 4, the numerator. So the cube root of 8 is just 2. It doesn't matter which order we do these in. We could raise 8 to the power of 4 first and then cube root whatever that is. But generally it's easier to cube root first, or it's easier to take the denominator in the power and apply that first. So the cube root of 8 is 2. So this is equal to 2 and then raised to the power of 4. So 2 to the power of 4, which is 2 times 2 times 2 times 2. 16. Alright, let's try that with another example. Let's say if we've got 27 and that is being raised to the power of 1.6 recurring. Now that looks a bit confusing, but if we change that power to a fraction first, it makes it much simpler. That as a fraction is 5/3. So first of all we need to cube root 27. So the cube root of 27, that means the number that cubes to make 27, and then raise it to the power of 5. So the number that cubes to make 27, well 3 cubed is 27, 3 times 3 is 9, times 3 is 27, so the cube root of 27 is 3, and then we need to raise it to the power of 5, which would give us 243. 3 times 3 times 3 times 3 times 3, 243. Alright. Now let's look at what happens if we have a fraction. Let's say we've got 81 over 10,000, and we're going to raise that to the power of, let's complicate it as much as possible. Let's put minus 3/4, minus 0.75, minus 3/4. Alright, so that means we have to mix a few rules together here. We've got a negative power, so first of all let's deal with that. We can take the reciprocal of our fraction, so 1,0,0,0, 10,000 over 81, and then we can make the power a positive because we flipped it upside down. So 81 to the power of 3/4, so we've made the power positive now because we flipped the fraction upside down, and 10,000 to the power of 3/4. If you're not sure what happened there, check out the last couple of videos. Alright, so 10,000 to the power of 3/4. Well, that means we need to take the 4th root of 10,000 and raise that to the power of 3. The number that multiplies by itself 4 times to make 10,000. So let's write that out. So 4th root of 10,000 cubed. And then we're going to do the exact same thing to the 81, so the 4th root of 81 cubed. Alright, so the number that multiplies by itself 4 times to make 10,000 is 10. 10 times 10 times 10 times 10 is 10,000. So we've got 10, and that's being cubed. And the number that multiplies by itself 4 times to make 81 is 3, and that's also being cubed. 10 cubed is 1,000. 3 cubed is 27. So there you go. 81 over 10,000 to the power of minus 3/4 is 1,027ths. Alright, so one way to remember fractional power, one way that I like to remember it, is if you have x to the power of a over b, you can think of the fractional power, you can think of the power as a tree. I'm not very good at drawing trees. There we go. Because the bottom number is the bottom of the tree, which is roots, and we take that root of x, so it's the b root of x. So b is on the bottom of the fraction, and the bottom of a tree is the roots. The top of the tree is the leaves, which power the tree via photosynthesis. So the top number of our fractional power, the numerator, is the actual power. So think of a fractional power as a tree. Bottom number's the roots, top number's the power. So we take the b root of x to the power of a.